if you have your Chapter 8 notes packet, you can follow along in the 8.4 notes. Otherwise, I've posted a blank copy on the Google Classroom and in the lesson plans, or you can just follow along. Okay, so we're going to be modeling with quadratic functions. So we're going to read each scenario and then set up the problem. So for the first part of this lesson, you're just writing the equations and then submitting them and getting them verified before you do anything else. So an object has been thrown straight up in the air. The formula h of t equals negative 16t squared plus vt gives the height of the object above the ground after t seconds when it's thrown upward with an initial velocity v. So h of t is height. T by itself is time. And v stands for velocity. Okay, number 1. After how many seconds will the object hit the ground if it's thrown with a velocity of 144 feet per second? So, after how many seconds the object has to hit the ground, and it has a velocity of 144 feet per second. So based on the function template they gave us in the introduction, we know that you can find height at any given time if you do negative 16 times time squared plus, and we have our velocity, which is 144 times t. So that would be our function. So we have a place to plug numbers in and a place to get numbers out, except they're telling us we need the object to hit the ground. So when something is hitting the ground, that means the height is 0. So h of t becomes 0. So the only variable we have left is t, which stands for time in seconds. So when we solve this, we will be able to answer how many seconds it will take the object to hit the ground. And so right now all we're doing is setting them up. So we wrote our equation, so for now number 1 is done. So I'm going to leave number 2 for you to do. You will use this same setup for number 2. It just changes a little bit of the information, but you're still using that same function. Then 3 and 4 are also for you to do. I'm going to get you started on 5, and then we'll do 6 together. So number 5. The area of the rectangular slab of foam insulation in the illustration is 36 square meters. Find the dimensions of the slab. So we're talking about area, and we have a rectangle. So we know area equals length times width. And our area is 36 square meters, and it wants to know the dimensions. So dimensions would be length and width. So based on our picture here, we know one side of the slab is WM. So M here stands for meters, and W is our actual variable. So let W equal width. And then if you look at your picture, the other side is 2W plus 1 M. Again, M stands for meters. So length the length is 2W plus 1. So it's twice the width plus 1. And you know you are working with area equals length times width. So you know an expression to plug in for length, and width is just W. And they've also given you a number for area. So I'm going to let you finish that one, but you have to plug in the area and the expression for length so that you can have your equation. Okay, the last one, number 6. At a pharmacy, customers take tickets to reserve their turn for service. If the product of the ticket number now being served and the next ticket number to be served is 156, what number is now being served? So we're talking about a product, so the answer to multiplication. We have a ticket now being served, and so times the next ticket is 156. What number is now being served? So let x equal current or now ticket. And if x is the ticket right now, the next ticket would be the next number. So it would be one more than our current number. So x plus 1, the current ticket plus 1, which will give me the very next number, is the next ticket. So I know 156 is the answer to the current ticket times the next ticket. And that would be the equation for 6. Okay, so you have equations to write for number 2, 3, 4, and then you have to finish 5. And that's the very first part of your lesson this week. Good luck.